Hi Jessica, you got another question. This is question 9 from January 2008 C1 paper at Excel. We're given the curve C's gradient function, dy dx equals 3x minus 1 squared. We're also told the point P lies on this curve with coordinates 1, 4. And we are asked to find an equation of the line that's a normal to C at P. So the first thing I want to find out is I want to find out the gradient of the curve at point P here. To do this is actually the easiest part. I've got the gradient function and I want the gradient. All I have to do is substitute in the x value, and we've been given the point so I can see its x value as 1. So I can find the gradient 3 times 1 minus 1 all squared. 3 ones are 3, minus 1 is 2, 2 squared is 4, the gradient is 4. Now, I know that the gradient of the curve at point P is 4, so a tangent would also have a gradient of 4, because a tangent to a curve has the same gradient like that. But what we're after is a normal. That's at 90 degrees to that. It's perpendicular, in other words. As a result, we can find the perpendicular gradient using the inverse reciprocal. The gradient of the normal would be equal to minus a quarter. I've turned the 4 into a quarter, and I've changed it from positive to negative. Now what I can do next is I can use the fact that I've got the gradient and I've got a point to get the line. If I want to do that, I can say that y equals mx plus c, and I can substitute in the point's coordinates. Y is 4, m is minus a quarter, x is 1, and I've got plus c. Now I've only got c as my unknown, so I can solve for that. Timesing by 1 does nothing, so really what I've got is 4 equals minus a quarter plus c. If I add a quarter to both sides, I've found c. Now I've got m and I've got c, I can form an equation. In the mark scheme, rather than being 4 1/4, this might be given as a top-heavy fraction. So it might instead be written as 4 times 4 is 16, 17 quarters. That's part A done. In part B, it asks us to find an equation for the curve in the form y equals mx plus c. Now we can do this because we've got the gradient function. I can reverse the process that would have given us the gradient function. Differentiation would have turned the function to the gradient function. Reversing this with integration will allow me to get back to the original function. However, before I integrate, I need to get it into the form of the ax to the n. To do this, I'm going to expand these brackets. Some people like to just apply the squared to the brackets, but I find students often make mistakes if they do that. So having the bracket repeated and then using FOIL or crab claw, you can get the method that you like. Now that I've expanded that, this is dy dx, y will be equal to the integral of this. In order to integrate this, I need to increase the power and then divide the coefficient by this new power. 9 divided by 3 is 3. Over here, the power increases and the coefficient is divided by this new power, so minus 6 divided by 2 is minus 3. Where there's a constant, we end up with a linear term. you can think about x to the 0 being 1 and think that you increase the x to the 0 to x to the 1 and the coefficient's been divided by 1. So if a constant of 7 gives you 7x, a constant of 5 gives you 5x, a constant of 1 gives you 1x. Of course, at this point we need to have plus c, but we're going to resolve that in a moment. The reason being is this equation, I know that the point given, p is 1, 4, fits on this. And I can find c by substituting in. Y is 4, x is 1. 3 times 1 cubed minus 3 times 1 squared plus 1 plus c equals 4. Well, if I evaluate all the numerical parts, 1 cubed is 1, that makes 3. 1 squared is 1, times by 3 is take away 3, so I've got 3 take away 3, so that's nothing. I've got 1 plus c equals 4. C must equal 3. Therefore, I can now rewrite this equation. I've run out of room, so I'll do it verbally. Y equals 3x cubed minus 3x squared plus x plus 3, because c equals 3. Until I'd substituted in the values given in the point and solved, I couldn't find c, but now I have found it, I should write that out to provide that answer. It appears that you've answered part C. But it looks a little bit like you might want some help with it still. So I'll go through that now as well. I'm going to leave this here in case I need it. That was the expanded version from earlier. In part C it says dy dx equals 3x minus 1 all squared, or rather using that, show that there is no point on C at which the tangent is parallel to the line y equals 1 minus 2x. Let's look at this. Y equals 1 minus 2x. If I was to rewrite that, I would get y equals minus 2x plus 1. That's got a gradient of minus 2. So what they're saying is there is no point on C where the tangent is parallel to this equation. In other words, there's no point on C where the tangent has a gradient of minus 2. Let's have a little think about what that would possibly mean. That means that there's no point on the curve where the gradient is minus 2. So looking at this, they're saying that that can never be equal to minus 2. Well, why? Well, let's look at what would happen. If inside this bracket here, if that was negative and I squared it, because of the squared here, it would be positive. If you square something, it's never possible to come out with a negative. It's never possible to come out with a negative answer in any real situation. Therefore, we can't get a negative value. Since the tangent would have the same gradient as the curve, and the curve can never be negative, then you can never get a negative tangent.